We are going to start today on page 32 in your notes packet. And we're going to talk about scatterplots, correlation, and interpreting information from a scatter plot. So we're going to look at 3 different models for today. Everything that we look at for our scatter plots is either going to be something we can describe as a linear model, an exponential model, or a quadratic model. And we've seen all these types of functions before. So basic form for linear model, for an exponential model. We have a plus or minus here because if it's exponential growth, it would be 1 plus that rate. If it's exponential decay, it would be 1 minus that rate. And then for our quadratic model, we've got some standard form there for us. So we're going to take a look at the bottom of page 32. We've got 3 different tables of values here. So we're going to use our graphing calculator to make a scatter plot of this data. And then we're going to determine which model of the 3 that we're going to focus on, linear, exponential, and quadratic, which of those models best fits the data that we've got here. So I'm going to pull up my calculator. And I want to recreate the tables for my notes in my calculator. So I'm going to add a list and spreadsheet. The first thing I'm going to do is name my columns. So I'm going to use the same names that my columns have in my notes. So they're X and Y, so I'm going to use X and Y as well. And then for number 1, my X values, I'm just going to type in this first column here that I've labeled X. Don't forget when you're using negatives to actually use that negative key on your calculator. And my X values are out of order, but that's okay. I just need to make sure I line them up with their appropriate Y. -6, and another -6, and a -14, 0, and 6. Okay, don't forget to enter after you type in your last value. And then I'm going to hit the menu key. Or actually, hang on, let's get out of here. I'm going to do Control Doc to add a page. I like this on a big page. So I'm going to add a data and statistics page, and I get these dots that pop up here. You can do it as a split screen. I like to do it on a full page. And then at the bottom where it says click to add a variable, I'm going to click down there and I'm going to assign this as my X variable. And then along the side here, click and assign my Y. And I get a scatter plot of my data. So you can see we go up, then we come back down. Now, I know that a linear function should look like a straight line. So either it should all be going up or it should all be coming down. So that tells me this is probably not a linear model. That would not be a good fit for this. Exponential models also either trend up, or if it were exponential decay, would trend down. So the up and down is telling me that this is probably a quadratic model. So I'm going to hit the menu key and go down to Analyze. What I want it to show me is a regression. That means show me the function that best fits this data. And then I want to have it show me a quadratic regression. Make sure you pick quadratic. There's another Q1 here. That's quartic. That's an X to the 4th function. That's not what we want. So make sure we select Show Quadratic. And then my calculator puts in that best fit curve for my data and gives me the function that it used. So I'm going to jot this down on my paper. I use a quadratic function. And my quadratic function is y equals -1x squared plus 7x minus 6. Be careful with your signs there. So -1x squared, if you just wrote that as -x squared, that's fine. And then here at the end, plus -6, I just wrote -6. So be careful with your signs there. So here is my model, my best fit model for my first set of data. Okay. Now I'm going to do the same thing again with my second set of data. So I'm going to pull my calculator back up here. And then you can, if you'd like, make an entire new document or a new problem. If you make a new page and then label your columns as X and Y, what's going to happen is the second that you pull up X, all of this data is going to auto fill in because we've already named something X. So be careful with that. What I'm going to choose to do is actually just rewrite over my old data. So I'm going to put in the data for table number 2, which starts with -1, and then 1, and then -2, 3, 0, 2. Works out nicely since the tables are all the same length. You don't have to delete anything like we've had to before. Okay. And then if I hop over, my scatter plot is also adjusted. Now a quadratic looks like maybe not the best option for this data. We come down, but we don't ever come back up. And if I take a look, it's already given me that quadratic model because I told it before to give me a quadratic model, but that's not a good fit here. So what I'm going to do is hit menu, go to analyze, and I'm going to tell it to hide this quadratic regression. Okay, so that's gone now. And let me see if I can get this to sort of readjust. Yeah, if I reassign those variables, it kind of readjusts the screen there for me. So this maybe looks like part of a parabola, but from that last view we saw it doesn't quite fit. It's also not quite a straight line. This is more of sort of an exponential curve, looks like to me. So I'm going to go ahead and hit menu, analyze. I'm going to go down to regression, and I'm going to have it show me an exponential model. And let's see how that looks. Yeah, that looks like it fits pretty well. So here's our exponential function here. So I'm going to jot that down in my paper. So this I used an exponential model, just putting that down in my notes. And then I'm going to write down the model that we've got on the screen there. So this would be 4 times 1/2 to the x power. If you wrote that as 0.5 instead of 1/2 in fraction form, that's fine too, but this is a pretty good fit. This curve fits our data pretty well. So for the second one here, exponential, and there's our exponential function. Okay. And now we're going to do the same thing for number 3. So I'm going to go back to my calculator. I'm going to go back to the spreadsheet page. And again, I'm going to write over my data. So we have 0, 2, -2, which I think was already there. And I probably could have just left it, but that's okay. And now I'll rewrite over my y information. Okay, there we go. And then I'm going to hop back to my scatter plot page. And this isn't even showing me that exponential curve anymore. So I'm going to go ahead and hit menu, analyze, hide that exponential. And then I'm going to reassign my x variable again so I can see a little bit better picture of my data. And this looks pretty linear, So I'm going to go ahead and hit the menu key, go down to analyze and regression. And this time I want it to show me a linear regression. We're used to functions in the form y equals mx plus b. So I'm going to select this first one. The second one just sort of flops the terms around, but I'm going to use mx plus b since that's what we're used to seeing. And yeah, that line fits our data pretty well. So number 3 was a linear function. And that function is y equals -4x plus 5. I've jotted that down on my paper. The idea here is that instead of having to do a scatter plot by hand, like you would have when you first learned about scatter plots, instead of plotting all of these points and then trying to fit in a parabola and then figure out the equation, we can have our calculator do that heavy lifting for us. So you would have done that by hand with linear functions probably at some point where you put in on a graph your x values and your y values and plotted them. And then you grabbed probably a ruler and tried to make the straightest line and hit as many points as you could. And if there were some below, there had to be about the same amount above. And you said, this is my best fit line. And so pick a couple of points and find the slope and then find your y-intercept and write your linear equation that way. Now that we have our calculators, we can actually just give our calculators the points and have it calculate that best fit line for us. This is especially handy when our best fit line isn't actually a line, when it's a curve like an exponential function or a quadratic function. We can let our calculator do that heavy lifting. Now, what we got here were models that can help me make predictions, and that's something that we'll look at in the future using those sort of correlation equations that we created to be able to look at something called interpolation and extrapolation, which we'll look at in the future. But these can help me figure out what to expect out of my scatter plot information. Let's go ahead and turn to the next page. And I want to talk about different types of correlation. Okay, so remember we talked about how correlation is not the same as causation, and that is down here in bold at the bottom. Correlation is not the same as causation. So when we talk about correlation, that means we're seeing a relationship between these two things. We think that, we have good reason to think that maybe these items are related in some way, but we cannot say that this thing that causes another thing, that X causes Y, or this makes this happen. We're just picking out patterns here. When we talk about correlation, there are a lot of different types that we can look at. We're going to focus for page 33 on just linear versus not, and then the strength of that correlation. So as we look at each of these, we are going to label them as a strong linear correlation, a moderate linear correlation, or a weak linear correlation. Remember, linear means a line, so these would all be things that fall in a straight line. And then strong nonlinear, weak nonlinear, so things that clearly have a pattern but aren't a line. And then no correlation. There is no relationship that I can see here. And then we'll talk about positive versus negative correlations. Okay. So am I trending up or am I trending down, particularly if I've got a line? As we look at number one, I can see that there is a pattern here. As my, let's say, X values get bigger, my Y values also get bigger. So I would say that this looks pretty well like a linear correlation, not the strongest linear correlation we can possibly have, but I do have a decent linear correlation there. I'd probably call this a moderate linear correlation. And I can see that if this were a line, it would have a positive slope. So I'm also going to call this a positive correlation. For number two, I definitely have a strong pattern here. I definitely have a strong correlation, but it's not linear. I'm not going in a line. This looks maybe like a cubic polynomial, the portion that I've got here. So I'm going to call this a strong non-linear correlation. That would be D. For number three, this is another linear correlation, and my points are pretty tightly grouped around where I would expect a line of best fit to be. So I'm going to call this a strong linear correlation. And again, this line would have a positive slope, so I'm going to call it a positive correlation as well. For number four, I can see that I do have a trend here. As my X values get bigger, my Y values get smaller. So I do have a trend here. Okay. I would say it's linear, but it's not a very strong correlation. So this would be a strong correlation. This I would call a moderate correlation. This is probably a weak correlation. So I'm going to call this a weak linear correlation. And then my line, my best fit line, I would expect to have a negative slope. So I'm also going to call this a negative correlation. Number five, another pretty strong correlation here. My points are really tightly grouped together. Okay. So another strong linear correlation, but this time my line would have a negative slope, just like it did for 4. So I'm also going to call this a negative correlation. And then for 6, I've got just a plain full of dots. My scatter plot is all over the place. I've got no trends that I can identify. I've, again, just got a plain full of dots. So this would be no correlation here. Now, no correlation doesn't have to be a plane filled with dots. It could be something that looks like this. This is also no correlation, although we don't have as many values in our data set. That's okay. No correlation here. I can't identify a pattern. And again, remember, as we're working on some of the problems that come with a context, correlation does not mean causation. That's a good thing to always have in the back of our mind, especially when we get to that interpret portion. That is it for our notes for today, just pages 32 and 33. And then we'll take a look at some problems together next time.